Hello, my name is Jenna Travers. I am an undergraduate researcher in the Cryohydro Remote Sensing Lab in the UO Geography Department, and today I will be discussing my research predicting glacier flood magnitude in high mountain Asia with remote sensing. So to start off, I'll be talking a lot about Glacier Lake Outburst Floods or GLOFs. These occur when glacier runoff uh, creates a lake that builds behind a dam that's either made of ice or like dirt and rock. And this lake grows and grows until the pressure is too much and it bursts through whatever the dam is. This is different than other types of flooding because it generally happens very suddenly. There's no predictors such as heavy precipitation or other factors like that. And so it's usually very sudden and people are not expecting it. It leads to severe flooding, infrastructure damage, destroyed villages, and fatalities. It's often also, these are occurring in remote areas like the Peruvian Andes and the Himalayas, which makes them really hard to monitor and prepare. So even if people could access these lakes, it would be really difficult to bring in the necessary equipment and actually get it to these very inaccessible places in the high mountains where these lakes form. And so this makes it really hard for downstream communities to adequately prepare for these sudden flooding events. Additionally, a lot of these areas are very rural and only have a few routes to other larger areas. And so if these flooding events take out infrastructure like bridges, it can cut off vital transit routes. And that's actually what we saw in 2022 for the Schiffsberg Glacier, which is pictured on the right here, and this glacier lake, which will eventually burst through and create a glacier lake outburst flood. Remote sensing, just a quick overview of that. It is a very wide field. For my research, I am only looking at satellite optical imagery specifically taken by this satellite, the SuperDove satellite, which is run by Planet, which is just a company. And I am also looking just at passive remote sensing, so not LiDAR, not radar, not anything where the satellite is emitting something and then receiving other information back. It's just taking photos, sensing reflected sunlight that's being put back to it. And remote sensing is potentially really useful for GLOFs because we can detect the lake area, we can detect the growth rate, we can detect the volume as long as we have some sort of elevation model. And all of these could be really important factors in GLOF timing and magnitude. So you can see in this right GIF that's running, these are all images that were taken by the SuperDove satellite and show the progression of this lake as it gets bigger and bigger from starting in February until it finally bursts through on May 8th, right there. The issue is that we don't actually know if the things that remote sensing can detect are the important predictors. And so, although we can look at lake area growth rate and volume, and those might be the predictors of GLOFs, it could be ice dam thickness or runoff rates, and those things can't be sensed. So we are really with this study, I really wanted to see whether or not the objectives of remote sensing were even useful and what it can detect and whether or not that those could be used. And additionally, spatial and temporal resolution can really vary for regions. So especially in these high mountain areas, there's typically a lot of cloud cover, which means that the temporal resolution, we can't get imagery very often. And especially when satellites used to only take images every 2 weeks, if that day was cloudy, we didn't have imagery. Now they're getting better, but even still, there's some issues with that. And similarly, spatial resolution, if it's not high enough, can lead to some variability in predictions. So this leads to my research questions, which are very, very closely tied to that of just, can remote sensing be used as a predictor and early warning signal for GLOFs? And then how does the area and growth rate, which are two things we can measure, of a glacier lake affect the timing and magnitude of the flood event? So going into methods, the study area looks at the Schiffsberg Glacier in the Karakoram region of Pakistan. And in this region, a lot of the GLOFs that occur are occurring due to surge glaciers. So you can see it's situated kind of in the area in between Tibet and in northern Pakistan and then north of India, but it does go in between there. I'm only looking at this one small area, but a lot of the surge glaciers are also kind of spread between those three countries. And when these glaciers surge, we see it's here, the Schisper Glacier is surging down. It blocks off other glaciers whose runoff then create this lake. So this lake is actually fed by the Muchahar Glacier, which would be up here, and its runoff is creating this lake that's dammed by the ice found from the Schisper Glacier. And so this lake is actually flooding annually, which makes it really interesting to research because a lot of times they happen very far apart and we don't know if there are other factors, but this one has been happening for the past 3 years, 2020 and 2022, which makes it a really good study spot. And you can see here, it's zoomed out a little bit on Google Maps, and this shows the town of Hassanabad, which has been one that has been suffering a lot of the damages. So what did I do? The first thing I did was just import images from Planet, which is the site that runs the satellite that I was using. And I approximately looked for images from every 2 weeks to track the lake formation. And I started with when the lake first started, usually in about February, until the GLOF occurred, which was in May or June. And I also looked for ones with a lower amount of cloud cover. So this is what that looked like, just downloading scenes from that. I then uploaded these to QGIS and made a true color raster, which just looks like a normal image, and a normalized difference water index. You can see the bands that I actually used for that. This index essentially just allows us to tell water apart from other things. So this is really helpful because sometimes it's hard to tell if something is rock or ice or water. And you can see here a very clear outline of the lake, different from this ground over here and the ice right here. And this made it easy to create polygon layers. And so I just traced around each lake for each time, for each year. And then I found the lake areas, calculating it just in QGIS, and then I could create the growth rates and lake area tracker. So for the actual data analysis, I plotted a few things against each other. So first, the GLOF magnitude. I just was using the relative average river width on the day of the GLOF. So using imagery from the 3 different dates, I found the river width at 4 different locations along and then averaged them. And you can see this is for 2022, what that ended up looking like. This is one standard deviation, is that kind of blue highlighted line. And you can see that most of the things leading up to the day are within that standard deviation. And then all of a sudden on the day of the GLOF, it spikes up by quite a bit. And so that was the magnitude. For timing, it was just the day that the GLOF occurred, and then I could plot that against the other values to see if there was some sort of threshold value in lake area or lake growth rate where a GLOF would occur. Oops, sorry. Finally, in lake growth rate, you can see in this bottom one, I used a linear regression in the months leading up to the GLOF, and using the trend line, as long as the R² value is good, using the trend line value to the slope of that to be the lake growth rate. And I did this for all 3 years. And then I plotted these against each other, looked at trend lines, and used the R value to figure out their R² value to define their significance. So results and discussion. First, GLOF timing. And I decided to show this with lake area. Lake growth rate was similar. And what I found is that lake area cannot be used to predict GLOF timing. So you can see with the first 2 years, I was pretty excited. I thought that it was going to be a great predictor, and because they're so close. And I did find an average lake area that it would occur at. However, in 2022, the GLOF occurred when it was significantly lower, which means that this is not a good metric because based on the first 2 years, we would not have expected this GLOF to occur when it did. And so this is not a good predictor of timing as a result. And similarly with lake growth rate, there was also not a good correlation between the two, and the threshold was not useful. So 2022 showed that this was not a useful metric. It could not be used to determine GLOF timing, and that it's probably something that we can't detect with remote sensing that might be a more adequate predictor. For magnitude, lake growth rate had a positive correlation between the rate and the magnitude of the GLOF. So like I said, I found this magnitude finding the river width, and as you can see, as lake growth rate increases, the average river width on the day of the GLOF also increases, meaning that the magnitude of the GLOF increases. And so this shows us that a fast growth of a lake leads to a more severe and damaging GLOF. And this is really important too, because if you remember on this last graph, the 2022 lake area was the smallest, but it led to the highest magnitude flood. And this actually, I'll show a picture later, ended up destroying a bridge. It left people stranded for several weeks because it was the main transit route to the rest of Pakistan. And it was a really big problem. And so we can see that it's not actually the lake area that matters, but the growth rate when we're talking about flood magnitude. And I will talk more about where I'm going with this next. So just conclusions, as I said, timing, remote sensing, the things that we can detect with remote sensing are ineffective for predicting when a GLOF will occur. This is both for lake area and growth rate. It's also for volume, although I didn't focus on that as much here. It is not an effective way to figure that out. There are either other predictors that lie outside of remote sensing, or it's something that is going to be better with monitoring, or there isn't a trend. But the things that we can detect with remote sensing are not useful for predicting the timing of GLOFs. That being said, magnitude, there was a positive correlation between growth rate and magnitude. And so this is really important because that means that downstream communities can monitor the growth rate of the lakes upstream of them in order to predict the size of the GLOF and prepare themselves for this. So making sure that they have adequate supplies, making sure that they are tracking infrastructure and that sort of thing can be really useful on the actual, if they can see that the lake growth rate is expanding a lot. And so that leads me to future research. As said earlier, here's an image of the actual bridge breaking due to the Travers Glacier Outburst Floods. This was in 2022. And then this map, I just like shows the Karakoram region really well. And every single one of these red dots is a surge glacier. So you can see it's a very common thing here. So first future research point, I would like to look at other surge glaciers in the Karakoram region and see if their GLOFs act similarly or if this is just this Travers. And then I'm also interested in whether the GLOF hazard assessments, if the metrics they are using include remote sensing and how remote sensing could be included. And then finally, I come from a social science background, and so I'm really interested in the socioeconomic impacts of GLOFs. Recent research in Peru has shown that communities downstream of GLOFs don't actually think about them as much as Western scientists would like to think. And so looking into see whether GLOFs are really a big issue within downstream communities, or if they're just a flashy hazard that like news organizations and scientists like to focus on, and looking into how partnerships, not just community-based research, but community-led research, change the GLOF research focuses, and whether or not we can be researching different aspects of GLOFs or glaciers or downstream communities that actually help these communities. Thank you.